Agents are basically a system that can pursue their environment, make decisions, and take actions to achieve specific goals. They don't just generate the text, they actually act. Think of tools like Copilot, Claude, and with tools like Windsurf, Klein, RO Code. These are examples of agentic systems that orchestrate the task. On the other hand, we have LLM, which are the foundation. They are sophisticated AI models trained on massive amounts of data. They are great at understanding and generating a language, and examples include like ChatGPT, Grok, Claude, Sonnet, and Perplexity. The key difference here is the LLM gives you the intelligent, but an agent gives you the action. Agents are built on LLMs by using their reasoning power and then actually doing things in the world like running queries, calling APIs, or interacting with other systems. Today's focus is how agentic AI connects with your database through MCP. Why is this important? Because databases are where your most critical information lives. If we can bridge agentic AI with Oracle database, we can move from simply asking questions to enabling AI that can securely plan, act, and collaborate with your data systems. Now, let's take a closer look at MCP. So it's basically an open protocol that standardizes how applications provide context to LLM. I like to describe it as the USB-C port for AI applications, a universal connector instead of a messy tangle of custom adapters. On the left side of the diagram, you see before MCP world, each LLM integration requires its own unique API. For example, for Slack, Google Drive, and GitHub, every connection is custom, creating complexity and duplication. On the right, after MCP, everything is unified. LLM connects through the MCP, and MCP handles those integrations in a consistent way. The key benefits what you get with MCP are a standardized interface for LLM data connections, and it simplifies the integration. We move away from end-to-end problem to just one protocol, and we get built-in tool and data discovery capability. And critically, security and access control are part of the design. This was introduced by Anthropic in November 2024 as a open source protocol, and it's quickly being adopted across the industry. Let's take a look at how the MCP architecture works. At the core, there are three components. One is MCP client, one is a MCP server, and the data source. MCP client, the LLM-based assistant like ChatGPT or Claude, which makes the request. The MCP server, which acts as a mediator and handling access to tools and data sources. And the data source, this could be an enterprise system or a database or APIs. Let's walk through the protocol flow. Basically, the client sends a standardized JSON RPC request. The server checks for permission and it validates the request and routes it appropriately. The data source executes that particular request, maybe fetching rows from a database or pulling a file. And the server then packages up the result and sends it back to the client in a consistent format. The key feature here is MCP is a stateful protocol with lifecycle management. That means the client and server can negotiate the capabilities and manage sessions and maintain the context. So it's just not a one-off API call. but a robust conversation between AI and your data system. If you look at the architecture diagram here, you can see the flow visually. An AI assistant makes a request, and the MCP server handles that particular request, and the data source executes it, and the results come back from through the same channel. In the traditional setup, the tools are loaded directly into the agent. You can see in the example, you are basically embedding things like a math tool or a Python REPL straight inside the agent. The problem with this approach is there are no restrictions. Tools are always available in context, whether you want them or not. There is no control over how those tools are discovered or executed, and not a better uh, auditing or logging for compliance. And if you want to update a tool, you actually have to change the agent code itself, which is messy and hard to scale. And MCP solves this. You can see how it uses a secure session-based protocol for tool access. The tool server mediates all invocations, so the agent never calls the tool directly. Tools are discovered dynamically at runtime through the metadata, and every execution is routed through the MCP server, giving you a consistent control pathway. For enterprises, MCP also adds extra features like auditing and rate limiting for compliance and governance. And you get a tool versioning and controlled rollouts. You can upgrade quickly and safely, and secure execution in isolated environments, which is critical for sensitive data. And here's where MCP really shines, separating your tool discovery from the tool execution. On the left, we have tool discovery. The agent can see what tools are available, and it gets the tool names, human readable descriptions, and input fields and types needed to use them. So the agent knows what it could do, but the actual tool execution shown on the right is handled very differently. The agent constructs valid calls, but every execution is routed through the MCP server. Importantly, tools are never run locally within inside the agent process. Yes, Marcus, we will share the recording. And the key differentiator here is you get full transparency. The agent basically knows your tools, and execution is always in a controlled, audited, and secured through the MCP server. This enables features like auditing, rate limiting, tool versioning, and isolated secure execution. The transport types in MCP defines how clients and servers basically communicate. We have two main options. One is STDIO transport, and the other is SSE or HTTP transport. STDIO transport uses basic standard input or output, and it's great for local communication, and it gives high performance and best for desktop applications or embedded systems or local tools. When it comes to SSE or HTTP transport, it uses a streamable HTTP protocol designed for remote or network-based communication, which is ideal for cloud services and distributed applications. And now that we have seen what MCP is and how it works, let's bring it into the Oracle database world. Oracle database integrates MCP through SQLcl, which is a database tool, which acts as an MCP server. What that means is, instead of just being a command line tool for running SQL, now SQLcl can now expose database capabilities securely through the MCP protocol. This is powerful because it allows an AI agent to not only generate the SQL, but you can actually run queries, and you can inspect your results and perform diagnostics and even automate database tasks all in a controlled and auditable way. And basically, if I tell it in other way, SQLcl becomes the bridge between your database and agentic AI. Wasim, I'll show it to you in the next coming slides how to install SQL and how basically it works as an MCP server. This AI capability is available across all Oracle databases, delivered through MCP server feature in Oracle SQLcl. Um, we will dive deeper into MCP and SQL in just a moment, but the key idea is that it acts as a bridge between your LLM and your database, and it is available at no extra cost. With this bridge, your AI assistants are not limited to what they are trained on, or to long prompts and retrieval augmented generation. Instead, they gain a set of powerful interactive tools to work directly with your database. And Oracle SQL CL version 25.2 makes all of this possible. And cursor desktop applications loaded with popular client extension makes it easy to access powerful LLMs to interact with your Oracle database because of our MCP server support with SQLcl. We will also be adding new tools on a regular basis for things like data guard, data loading, security analysis, and design review. What you would like to see, what tasks are currently bogging you down, specific tools allows you to deliver a more predictable and reliable answer or outcome when the LLM goes to perform work. Hey, hi, Eric. You can work with an open source frameworks as well, like LangChain or LangGraph, with Hugging Face repositories and all, and you can build your own agentic AI with Oracle database. It's also possible. But here in this session, we are more focusing on SQL CLS and MCP server. For example, if you are not using VS Code and our SQL developer extension, it's still quite easy to install SQLcl and configure it. With you have to go to this particular URL and download the zip file and install it with brew or yum based on your machine. And if you are using VS Code and our SQL developer extension in the VS Code, and also using Copilot, you basically doesn't require any configuration. You just have to define your database connection. And perhaps the easiest way to get started with MCP server is via Virtual Studio Code, VS Code, and our SQL developer extension. SQLcl and the MCP server are automatically included and configured for Copilot. If you are not using Copilot, and there are tons of AI assistant extensions available, for example, you can download client extension in VS Code, and you can configure SQL MCP server for that client extension, and you can start using that. Basically, to get started in VS Code, just search for Oracle or SQL Developer in the VS Code marketplace and install the particular SQL Developer extension and the client extension, and just configure SQLcl as an MCP server, and you are good to start with. Basically, the focus has to be more on the security. AI, LLM, or MCP amplify that security is more important than ever. And please follow the least privilege principle. Use connections tied to database users having only the briefs to view the data you want to share and perform the action you want an agent to do on your behalf. And have a segregated environment. Use databases that have sanitized data, such as development and testing instance. And production use should be strictly monitored. And basically, do not trust the LLM. Whatever the task and action you are performing, please always verify, and use only AI assistant that asks for access to the SQLcl MCP tool, and always review the required action, what that particular LLM is going to run in the database before approving them. Never enable auto approve. And for complete and total transparency, we instruct the AI to identify itself when interacting with our tools. We use this information to instrument the program, module, and account details in $V session. Additionally, the tool is also instructed to include a comment, like in this case, LLM in use is GitHub Copilot. In the SQL, it basically generates. This makes it an easy to find in audit trails or active session history report and other database management and monitoring interfaces. Eric, CL MCP server works with 19C as well. And that's not all. If your connection isn't read-only, we also have inventory where single interaction with your database in the connected user schema via DB tools $MCP underscore log table. The use cases are bound only by the the information what you have in the database, and the privilege or the data access level to that particular connected user, and the imagination of the prompt engineer and the capabilities of the LLM. And as we know that AI assistants are great for automating tasks, providing information and enhancing communication. They can control devices and answer question and generate content including code. They make our tasks easier, saving us time, and ultimately helping us accomplish more. Regardless of how you might interact with the Oracle database, you can probably imagine some tasks you would love to make it easier. AI is not just for developer. Today's modern LLMs are great at working with Oracle via SQL, PL/SQL, and its APIs. Let's imagine a few scenarios together so we can see what's possible today, not tomorrow, with your existing Oracle databases and your favorite LLMs. Uh, let's take a look at some of the theoretical examples. Basically, your administrators, um, imagine asking your assistant to find you the worst performing query in your database and to tune it for you, delivering a full report of its findings with executive level suggestions and plan. And basically, what the report you see on the right hand side, it was generated using Claude Sonnet 4 LLM against 23 AI Oracle database via the MCP server, and the total queries it run to come to this particular end result is 5. And and it is giving you the same result in a different format here in the bar charts and all that, with average execution time and the query performance comparison chart. And the LLM is even generous enough to provide an action plan for us, so we can prioritize the suggestions, fixes to our particular problem, and so we can get the immediate relief. A few comments, we ask the LLM to generate an executive summary. And if you are presenting a database performance problem to an executive audience, at the end of the day, they wanted to understand how big the problem is for their particular business. And you will notice at the end of the report, it also gives you an estimated cost savings of $50,000 that's needed for this type of report. But the DBA or engineer needs to step in and evaluate the role of the query being tuned and how much revenue flows through the application via this query. Even the LLM doesn't do the job 100%. It gives the Oracle database professional a huge head start and a guideline or a plan for getting it to the finish line. Or maybe you need to analyze some data and you need that data in your database for your future usage, and taking an CSV file, and we can load data to a new table in our database and even document it via column and table comments from an existing model. With a fairly simple prompt, we can ask the LLM to look for patterns in your data and visualize those on an interactive map in only a few minutes. And LLM generated a total of 8 queries and executed them, analyzing the results as it went to generate the report we asked it for. Contrast this to a person clicking or querying through the tens of thousands or rows in our tables and finding the trend and piecing them together and finally coming up with a summary report. It can be quite handy to store our spatial data alongside our relational data, making map rendering quite simple with Oracle database conversed platforms. And 23 AI isn't required to access this particular technology, but our 23AI database has a tons of features that LLM can help us take advantage of, like our vector database support in 23AI. And LLM can be coached to learn how to load your LLMs via ONNX models to your database and have it vectorized your data and do similarity search via prompt or a response. The LLM can be directed to blog posts that demonstrate how to particularly accomplish a specific task. For example, here I have asked in the prompt, use an official Oracle blog for how to load an LLM to the database via its ONNX model file directly from a object storage bucket. And we prompt it to generate a new table in our system and create 10 random strings, load an LLM to the database and vectorize the data, then do a proximity search to find the phrase most similar to our seed. Basically, if you are using VS Code and you have an client extension and you have an SQL developer extension, it does work with local LLMs as well, and you can leverage your on-premise databases too. Basically, if you are using VS Code and you have a client extension there, I basically wanted to show the workflow, and you have a SQL developer extension where you connect it to your Oracle database and you basically ask a question. That is, you basically state your task. Here, the task for the LLM is connect to the Oracle database. And then it goes, and because here in this particular example, I'm using client extension, and the LLM sees a tool that might be of assistance, and it is basically seeking your approval whether I would like to use this particular list connection tool or not. And in this example, we are using Claude 3.5 Sonnet model. And once we click the approve, then it basically gave a response that you have two databases here. One is pluggable DB and another is test DB. And client is also wants to use a tool on the SQLcl MCP server. Now it says, I would like to use this particular tool called Connect, and would you like to approve? And this is the pluggable database I would like to make a connection. And if you click on approve, and then again, as a user, what I'm telling to the LLM is, please connect to the pluggable database and let me know the database size. And it still wants to use that connect tool because it has not made any connection to the pluggable database yet. And then once you click on the approve, and it says it was successfully able to establish the connections to the pluggable DB. And now, because in our task or a question to the LLM, we ask connect to that pluggable DB and let us know the database size. So the action is not yet completed, so it wants to again try to connect to a tool on SQLcl MCP server. Now the tool is run SQL, and it's basically would like to run this particular query and use this particular model. And if we click approve, then it gives us a response that the size of the database is this much, and it gives you an completion of the task. It was able to successfully connect to your database and give you the database size. Eric, basically SQLcl is a database tool. With the help of that, you get a lot of commands where you can connect to your database. And basically, you need to configure, if it is an on-premise kind of a setup, you need to configure SQL configuration file, and then you can use the LLMs. And the takeaways from this session would be, how we can build agentic AI with Oracle Database 23 AI with our SQLcl MCP server. And this is a free MCP server with SQLcl, which is one of our database tool, and which is secure and supported. And if you would like to have some more information on this particular topic, you can download SQLcl and try it. And you can also look at our Oracle MCP server blog post. And there is a lot of documentation available on how we can use SQLcl as an MCP server. And you can also leverage SQL Developer extension with Virtual Studio Code. And you can use SQL as an MCP server. Sure, Wasan. Give us a 1 week time. We will share the recording. Basically, I would like to show a demo where one of my colleague has performed using Claude Desktop. Basically, here we are using a prompt called list connection, and using the list connections, it gave you the available Oracle database connections, the databases. And here we ask the LLM connect with this particular demo Claude database and generate an AWR tool. And it connect to the demo Claude using this connect SQL tool. And afterwards, and it made a connectivity to the demo Claude database, and it is trying to run this particular tool called run SQL, and trying to generate it is looking for available snapshots and then create the AWR report. And it found recent snapshots available, and using this particular snapshots, it would like to create an AWR report using run SQLcl tool. And it is trying to use this particular run SQL, and it was able to generate an AWR report, and it gave us a good information about the findings of the AWR report, like database information and the key performance metrics like load profile, the top events, key observations, and the service activity. And also it gave you a few of the recommendations, what we can do to make sure a database is up and a database is good with is performing well. As of now, I think it doesn't have Select AI as a tool in SQLcl tool inventory as of now. So for now, it doesn't have a tool as Select AI with SQLcl as an MCP server. Thanks, guys, for joining this session, and I hope it was very useful. Thank you.